Hello guys, how are you today? So today I'll be explaining the mechanics AMS of term 1 week 7. So without further ado, I'm a bit late. Let me just get started with the video. A possible equation of motion of a particle moving in the positive direction at a constant speed. First of all, in the positive direction, this means that it's plus. Now, at a constant speed, when we say that we're dealing with a constant speed, this means that it is UARM. UARM means only velocity, okay? Only velocity, and the velocity is constant, right? And acceleration is equal to 0. So in this scenario, if our velocity is constant and it's moving in the positive direction, that means we're supposed to have what? We're supposed to have a positive velocity. So now let us see. We will first of all cross out anything that has an acceleration, because our acceleration is supposed to be 0. Acceleration is anything with time squared, so we cross this out and we cross this out. Now we're left in between these three options. Now we said that our velocity needs to be positive because it's moving in the positive direction. That means we cross out these two and we're left with this option. Perfect. We'll move on to question number 2. Hopefully it will not take too long to load, because I don't know why the internet is slow. It's like really slow. Perfect. It took almost a minute for it to load. Anyways, let's go on to the second question. At time equals to 0, a spring gun is used to eject a ball vertically upwards at 12 meters per second from the top of a tower A. The ball reaches a maximum height B and falls back to the ground C. Neglect air resistance and take G as 10 meters per second squared. If the ball hits the ground at time 6 seconds. So what do we have first of all? At T0, meaning whatever we're going to have is going to be initial, a ball is ejected vertically upwards this much. That means this is velocity initial, velocity at the time being 0. It reaches a maximum height B and then falls to the ground as 10 meters per second squared, which is our G. Now, how do we take the value of our G? Okay, this is what we're going to discuss now. Before we do, we know that the ball hits the ground at a time 6 seconds. So the ball was at A, it went to B, and now it's all the way, it fell down at G. They want us to find the height of the tower. So from here to here, we would have what? We would have no displacement, because what is the definition of displacement? It's position final minus position initial. So over here, from this point here to this point here, there would be no displacement. However, the ball does not land at this point. The ball lands at point C, which is over here. So the displacement is going to be from point C to point A, which is the initial position. So what we are going to be looking for, which is the height of the tower, is the displacement. And displacement in free fall is denoted by delta Y. Why is it delta Y? Because the tower is standing on the y-axis, because this is the y-axis, this is the x-axis. This is why we call it delta Y. Now, what we need to look for is the height of the tower, which is delta Y. Now, delta Y is the displacement. If you look back into your memory about any of the equations regarding displacement and acceleration and velocity, you will come to this one equation, which is delta X is equal to 1/2 AT squared plus V initial T. Now, this is the equation we're going to be using. However, we need to change the terms into free fall terms. So delta X will change it to delta Y is equal to half of A. What is A in this scenario? The acceleration of A will always depend on the initial velocity. Now, in this scenario, we're throwing the ball upwards, right? So if we're throwing the ball upwards, and they told us that the initial velocity is how much? It's plus 12 meters per second. That means our acceleration is gonna be what? It's gonna be negative G. Why? Because when you throw it up, the ball, it goes like, it's changing position, but it's slowing down. If, like, for example, let me find the ball, or like, for example, I have a ball. I'm gonna throw my ball, you throw it, it slows down, and then what happens? And then it's gonna fall down. Like, it is changing position, it is having a velocity, because it's like moving and changing its position. So it does have a velocity. However, the acceleration, when you throw it, it slows down and then it falls again. So this is why we will say that if the velocity initial is positive, the acceleration is gonna be negative. But let's say our velocity initial was negative. If it was negative, try to throw the ball down. You will see that the ball speeds up, it does not slow down. So you throw it up, it slows down. You throw it down, it speeds up. So if velocity initial is positive, our acceleration is going to be negative g. If our velocity initial is negative, our acceleration is going to be what? It's going to be positive g. Now, in this scenario, our velocity initial is positive. That means our acceleration is going to be what? It's going to be negative g, t squared plus v initial squared. Now, this is the only thing we needed to change. Now we have all of the values we can substitute. So let us then substitute. It's going to be delta y is equal to 1 over 2 times minus 10 times 6 squared plus 12 times 6. You should put this on your calculator and you're supposed to get an answer of what? Of minus 108. Now this is what? This is the value of delta y. Now delta y from where to where? From point A to point C, this is what? Minus 108. But is this the height of our tower? No, this is just the displacement, because it went from point A all the way to point C. However, the height of our tower is what? The height of our tower is from point C to point A. So from point A to point C, it's negative. That means from point C to point A, it's going to be what? It's going to be positive 108 meters. So that is why it is what? That is why it is 108 meters. Let's move on to question number 3. This is a question from last year. The diagram below shows the VT graph of a moving object. They asked for the acceleration between 0 seconds and 2 seconds and the net displacement. Let's find them both here. First of all, they want the acceleration, right? In between 0 seconds to 2 seconds. We know that the acceleration in a velocity time graph is what? Is the slope. So in a VT graph, acceleration is what? Acceleration is the slope. So from point 0 to point 2 seconds, we will need to find the slope. If you find it, it's going to be y minus y over x minus x. So you chose this point and this point, this point and this point. So it's going to be what? It's going to be 4 minus 0 over 2 minus 0, which is what? Which is 2 meters per second squared. So the first answer is 2 meters per second squared. Now we'll move on to the net displacement. How do we find the net displacement in a what? In a VT graph? It's very simply what? It's very simply the area of the graph. So what we need to do is to find the area of the graph. We are given what shape? We're given a trapezoidal shape. So what's the area of a trapezoid? It's going to be base 1 plus base 2 times the height over 2. So base 1 is this over here. Base 2 is this over here. The height in red is this over here, and then you just need to put it over 2. So base 1, which in this scenario is from 2 till 6, so that's 4, plus base 2, which is 10, multiplied by the height, which is 4, divided by what? Divided by 2. So you're going to put it on the calculator, and you're supposed to get 28 meters. Perfect. We'll move on to question number 4. Hopefully it won't take time to load. Question number 4. Okay, perfect. Question number 4. A cyclist speeds up from what? Speeds up from 5 meters per second to 25 meters per second in 10 seconds. Then he travels at 25 meters per second for another 10 seconds. What's the total distance traveled by the cyclist? So whenever I receive something like this, I always prefer to draw what we have given. Now, as we can see, we have two values, which are what? Which our velocity and our time. So this is a VT graph that we're going to be dealing with. He starts from where? He starts from 5 meters per second, which let's say it's here, 5 meters per second. Then he speeds up all the way to 25 meters per second. In how much time? In 10 seconds. Then he travels at 25 meters per second, so constant velocity, for how much? For another 10 seconds. So in total it's now 20 seconds. Then what does he do? Then I think that's it. So this is all that he travels. So what do we need to do in this scenario? We need to find the total distance covered. Total distance covered is what? Is the area of the graph. So you can do this in many ways as long as you find the area of the graph. Preferably, you separate it into two shapes. This one is being area 1 and this one is being area 2. You find their areas and you add them together. So let us start with what? With the first area. So this is a trapezoid again. This is how much? This is base 1 and this is base 2, right? And this over here is what? This over here is the height. So base 1 in this scenario is 5. Plus base 2 in this scenario, which is 25, times the height, which is 10, divided by 2. So this is area 1. So how much is that going to be? 5 plus 25, that's 30 times 10 divided by 2. That's going to be 150. So I can, my bad, I can erase this and substitute it by 150. In addition to what? In addition to the area of the second one, area 2. So from here to here, this is 10. And from here to here, this is 25. So that's going to be 10 times 25, which is what? Which is 250. And 150 plus 250, that's going to give us our answer, which is what? Which is 400 meters. We move on to question number 5. Hopefully it does not take too long to load. Question number 5. Perfect. It loaded, but it took some time. A bus started from rest. What does this mean? This means V initial is equal to 0 at point A and accelerates at 2 meters per second squared. So this is acceleration for 10 seconds time. And then runs at a constant speed for 30 seconds another time, and then slows down at minus 4 meters per second until it stops at point B. Stops means that velocity final is equal to 0. So what I advise in this scenario, because we have multiple different unknowns, is to graph what we are being told. So first of all, we cannot graph an acceleration time graph. So what's the most reasonable graph to graph? It would be what? It would be a velocity time graph. So what happens? It starts from rest, meaning it starts from velocity initial being 0, and then it goes to a certain velocity, what? For 10 seconds. And how do we find this certain velocity, knowing that the acceleration, meaning the slope, is 2 meters per second squared? Very simply, we will find the value of the velocity by doing what? By doing the inverse of the slope, or by multiplying. So because it starts at 0, we can take it like this. We can take it that the acceleration, which is 2, is equal to V final minus 0 over time minus 10. Or no, sorry, 10 minus time, 10 minus 0. Because we choose this point and this point over here. So it's going to be y minus y over x minus x, right? So these will cancel, and we'll be left with what? We'll be left with the V final over 10 is equal to 2. That means V final is equal to what? V final is equal to 20. Now, at 20 meters per second, it runs at a constant speed for 30 seconds. So this is now what? This is now 40 seconds, because all of this is 30. And then it slows down from this point. How much? It slows down minus 4 meters per second squared. So we know that this is 20 meters per second. And it went all the way down to what? To 0, and we need to find the final time. So how do we find that? Very simply, again, you need to use the slope. You have the acceleration here, which is minus 4 meters per second squared. It is equal to what? It's equal to y minus y, that means 20 minus 0 over x minus x over 40 minus the final time, which I'm going to put it as t. Alright, so what can we say? We can say 20 minus 0 is 20. So now we can say that 40 minus t, after changing the equation, is equal to what? Is equal to 20 over minus 4. That means what? That means 40 minus t is equal to minus 5. Minus t is equal to minus 45. So the time is going to be what? The time is going to be 45 seconds over here, very simply. Now, is this what they're asking us for? No, this is just us graphing what they told us. They want the distance between A and B. So here is B, here is A. How do you find the distance or displacement on a velocity time graph? It's very simply the area. So we need to find the area of this graph of whatever we've drawn. So how do you do that? You're going to do, because it's a trapezoid, base 1 plus base 2 times the height over time. So from here to here, this is base 1, which is 30, plus base 2, which is 45, times the height, which is 20, divided by 2. So you put it on the calculator, and you're supposed to get an answer of what? Of 750 meters, very simply. We'll move on to question number 6. Hopefully it will not take a long time to load as well. Okay, perfect. Now we move on to question number 6. The motion of a car consists of 3 phases as shown in the table below. The car accelerates from rest at 3 meters per second squared until it reaches the speed of this. The car then moves for blah 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 and phase 3. So they want us to find the duration of phase 1, okay, like the time in phase 1, the distance traveled in phase 1, and the total time of the car's motion, and the total distance traveled by the car. So let us just remember, remember these, or have them open in the quiz, because I have them remembered. Or actually, let me see, can I scroll down with this? No, I cannot, so I'll have to... That's fine. I'm just gonna draw it here, and then we'll remember the last question. So phase 1, they want the duration of phase 1. When they say duration, means that they want the time. How do we find the duration of phase 1? I prefer always, when they give us something, we try to sketch it, right? So this is what? This is a velocity time graph, because we have acceleration. So whenever we have acceleration, it's directly a velocity time graph. They said that a car accelerates from rest. When it's rest, that means V initial is what? V initial is 0 at 3 meters per second until it reaches the speed of this. So it came at this speed, which is 18 meters per second. And how long did it take? This is what we need to find. But we are given what? We are given that the slope is 3 meters per second squared. Now, what did we say is the value of the slope? The slope is the acceleration. It's what? It's y minus y, so 18 minus 0, over x minus x time minus 0. So you can erase this. 0 minus 0 is 0. Or sorry, anything minus 0 will not change the number itself. So that means what? That means t is equal to 18 over 3. So t is what? T is 6 seconds. I'm gonna prefer to keep the graph. Oh my goodness, I erased that by accident. I'd prefer to keep the graph because it looks better and it will help us as well. So the time here is how much? It's 6 seconds. That means the duration of phase 1 is how much? It's 6 seconds. Now, the distance traveled in phase 1, whenever they say distance or displacement, we'll need to find the area of whatever we have graphed. So this is now what? It's a triangle, right? So this is our triangle in pink. We need to find the area of the triangle. So it's going to be base times height over 2. So 6 times 18 divided by 2, which is what? Which is going to be 54 meters. Now, last but not least, the total duration of the car's motion. So now we need to continue it all and try to find the total time driven by the car. What does it say? It says that the car moves a further 360 meters at a constant speed of 18 meters per second. So 360 meters at a constant speed of what? Of 18 meters per second. But how much is the time? How do we find the time? If they gave us a distance and we have the velocity. What's the equation? In a VT graph, the value of the distance with respect to the velocity is what? Is that the area, meaning whatever we have as the area, is equal to what? Is equal to the distance. So in this scenario, 360 meters is equal to the area of phase 2, which is what? Which is a square. So it's gonna be, here it's 18. We just need to find this value. My bad, it's a rectangle, not a square. So it's gonna be what? It's gonna be 18 times x is 360. So that leaves us with x being what? X being 20 seconds. So x is 20 seconds. This is 20 seconds, but in reality, this over here is 26 seconds. Perfect. Now let me just erase the arrows. Okay. Now we'll move on to the last phase, which is phase 3. It says the driver applies the brakes and the car decelerates to rest. So like this. In how many seconds? In 9 seconds. Just like that, we can find what? We can find the total time traveled by the car. So this is in 9 seconds, right? So in reality, it would be what? It would be 6 plus what? Or sorry, 26, which is the time over here, plus what? Plus 9. So it's going to be what? It's going to be 35 seconds. Now, what do we do? What's the total duration of the car's motion? We found it, which is the last time, which is what? Which is 35 seconds. Now, in the part under, they will ask us for the total distance covered. How do we find the total distance covered? Very simply, it's by finding what? By finding the area. So we can find the area of what we have graphed. Very simply, it's what? It's a trapezoid. So we can do base 1, which is from 6 to 26, which is 20. Plus base 2, which is the total, which is 35, times the height, which is 18, divided by 2. Of course, put it on the calculator, and you will get an answer of what? Of 495 meters, okay? So just like that, we answered all of the questions. This one was 6, this one was 54, and this one was 35, and let's not forget in the bottom, this one was 495. And now move on to question number 7. Hopefully it will not take time to load. Oh, perfect, it did not. The graph below shows the variation of a velocity of a dog during a given time interval. They want what? They want the average acceleration of the dog. How do we find the average acceleration of the dog in using what? In using a velocity time graph. Very simply, one word, and that is a secant. What does this mean? This means you have to take the time interval. So they said the first 5 seconds, meaning from 0 to 5 seconds. 0 seconds is here, 5 seconds is here. So the point is here and the point is here. So you need to take the secant of these 2 points, right? So now that we have the secant of these 2 points, we can find the slope of these 2 points. First of all, we know that this point is 0, 2, and we know that this point is minus 1, 5. So what can we do with this? Using this, we can find what? We can find the average acceleration by doing what? By doing y minus y over x minus x. So it's going to be what? It's going to be 2 minus 5. Or no, what am I doing? My bad, this is not minus 1, 5. This is 5 minus 1. My apologies. 5 minus 1. I said it by mistake. 1 minus 1, 5, and I wrote it. Okay. My bad. It's 5 minus 1. So now what do we need to do? We need to do y minus y over x minus x, right? So it's going to be y minus y. What's y? Y in the scenario is 2 minus 1 over x minus x. Of course, it needs to be corresponding. So 0 minus 5. Put it on the calculator, and you're supposed to get an answer which is minus 0.6 meters per second squared. So the answer here is minus 0.6 meters per second squared. Let's move on to question 8, and thank God it did not take too much time to load. Very important question. What do you need to know before this? Okay, before doing anything, what you need to know is two things. Speeding up, what does it mean? And slowing down, what does it mean? First of all, for speeding up, we have a condition is that the velocity and the acceleration should have the same sign, meaning velocity is positive, acceleration is positive. Or velocity is negative, acceleration is negative. For slowing down, on the other hand, we have a condition that velocity and acceleration have opposite signs. What does this mean? This means velocity could be positive, but acceleration is negative. Or velocity could be negative, but acceleration is positive. So now that we know this condition, we can now state whether it's, what's the sign of the acceleration. So a bicycle speeds up. We said speeds up mean the velocity and acceleration should have the same sign. In a positive direction, that means v initial is positive. So if it's positive, then that means the acceleration needs to be positive. It slows down. Slowing down means they have to have opposite signs. In a positive direction, velocity is positive. That means acceleration needs to be negative. Speeds up means velocity and acceleration need to have the same sign. In a negative direction, that means acceleration needs to be negative. And then last but not least, slows down in a negative direction. Slows down means they should have opposite signs. So negative velocity and positive acceleration. So the signs are positive, negative, negative, and positive. Now, they may get you a trick question, and where they're going to ask you about something being UARM, meaning that it has a constant speed. When they tell you it has a constant speed, then you will say that acceleration is equal to 0. Okay? We move on to question number 9. What does it say in question number 9? So, in question number 9, what characteristics of UARM excuse me, cause the VT graph to be linear? First condition, UARM, meaning we have acceleration, and velocity is what? Velocity is constantly changing. And it's like uniformly changing as well. Now, what causes the VT graph to be linear? What does VT graph mean? VT graph is like this, and linear. What causes this to be a straight line? It's very simply the acceleration. Now, what is wrong with the acceleration, or what's the problem with the acceleration, or what's the thing about acceleration that causes it to be a straight line? Very simply that it's constant. So here, check the slope, which is acceleration. It's the same as here, as here, as here, as here, as even here, or here. As long as it's on the same straight line, which means it's linear, that means the acceleration is what? That means the acceleration is constant. We'll move on to question number 10. What does it say in question number 10? Question number 10. Consider the velocity time graph of an object in motion shown below. The accelerations of the object in each phase shown are denoted by A1, A2, and A3. In which phase is acceleration the highest? Very simply, very simply. We're dealing with a VT graph. That means acceleration is what? Acceleration is the slope. So, what does this mean? This means the steeper the slope, okay, steeper, like let's say there's an increase in the steepness, that means what happens to the acceleration? It will increase, meaning it will have a higher acceleration. So, acceleration is the slope in a VT graph. The steeper the slope, the higher the acceleration. So that means which of them has a steeper slope? Definitely this has a steeper slope, meaning it's more like it's more it has a greater slope value, then this means what? Then this means that it is having a greater acceleration. So it's definitely phase 2. We'll now move on to question number 11. Perfect. I remember this question from last year. It's a very nice question. In the first leg of motion, a bicycle accelerates from rest. So let's draw what we're dealing with. From rest, okay, the bicycle accelerates. And for how many seconds? For 6 seconds, right? And what is the value of the slope or the acceleration? It's 1.5 meters per second squared. So what's the value of our velocity? It's gonna be what? It's gonna be 1.5 times 6, which is 9. Again, I explained it before. I'm gonna explain it now. Why did I do this? Because acceleration is equal to the slope. So it's gonna be y minus y over x minus x. So 0 and 0, you can remove them. You're gonna be left with y over 6 is equal to 1.5. That means 6 times 1.5 is y. That means y is what? Y is 9. So we have the value of 9 already. Then they tell us that in the second leg of motion, it decelerates to a full stop in how many seconds? In 5 seconds. So in total, it's 11 seconds over here. But now they're asking for what? They're asking us for the magnitude, pay attention, of deceleration of the bicycle in the second leg of motion. So how do we first of all find the value of the deceleration or acceleration? We need to find the slope of this graph. We have the point over here 9, and we have the point over here 11 or 0, sorry. So this point over here is what? This point over here is 6 seconds 9, and this point over here is what? It's 11 seconds 0. So we're gonna do y minus y over x minus x. So 0 minus 9 over 11 minus 6. That's gonna be minus 1.8, I believe, meters per second squared. Aha! Here comes the very, 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 very important thing. They want the magnitude. So you're gonna put this in absolute value, and it will be what? It will be 1.8 meters per second squared. Now, part B. Oh, we did part B before. Okay, I'm just gonna answer it because we did part B before. I'm not gonna waste any more time. So, greater than, smaller than, and then greater than. Let's now move on to question number 12. What does it say? I just love how, like, every time there's, like, mechanics or physics, the quiz takes its time to load. Like, it makes us very impatient, huh? Perfect. Question number 12. They told us that the diagram below represents the velocity time graph of a particle. The equation of its velocity is whatever. Now, I'll ask you something. Velocity time graph is an x, y, x graph, whatever. It's just a graph in general. And it has what? It has a slope. Do you remember? My bad. Do you remember from grade 8 or grade 7 even, the equation of the slope? If it's a straight line, yes, it's y equals mx plus b. Now, m in this scenario is what? Is the slope, which in this scenario is the acceleration, because the slope in a VT graph is the acceleration. And b is what? Is the y-intercept. Of course, you can solve this any way you want, but the best way, in my opinion, is to take what? Is to take b as the y-intercept. That means you go on the y-axis, which is over here, and you see at which point is the slope meeting with the y-axis in this scenario. It's meeting at which point? At point 2. The y-intercept is also what? Is also the initial velocity. Perfect, perfect. So now we have what? We have the value of b, which is v initial, which is what? Which is 2. Now, how do you find the value of the slope? You just need to do y minus y over x minus x. Choose any 2 points, for example, 12 and 4, and then 2 and 0 as well. So it's gonna be y minus y over x minus x. So 12 minus 2 over 4 minus 0, that will give us an answer of what? That will give us an answer of 2.5 x plus 2. Now, we don't have x in a VT graph. Instead, it's replaced by what? It's replaced by t. And we don't have a y in the VT graph. Instead, we have what? We have the v. So the equation is v is equal to 2.5t plus 2. Let's move on to question number 13. Hopefully, it will not take time to load as well. Perfect. Okay, in the velocity time graph below, the speed of a car at time 1 second is 1 meter per second. A straight line tangent to this point is drawn. They want the instantaneous acceleration. When you say instantaneous, not average, you need to take what? You need to take the tangent. And thankfully, they gave us the value of the tangent. And they also gave us a point on the tangent, which is what? Which is 1, 1. So it's up to us to find another point on the tangent, which, for example, I will take 5, 10, right? So now I have another point. What can I do? I will find the slope of the tangent, and just like that, I will find what the instantaneous acceleration. So it's going to be 10 minus 1 over 5 minus 1. That's going to be 9 over 4, which is 2.25, if I'm not mistaken. So perfect. Our answer over here is what? Our answer over here is 2.25 meters per second squared. Question number 14. What do we have? We have a VT graph below describes the motion of a particle tangent to the graph at point t equal 5 is shown by a dashed line. This tangent blah blah blah. Okay, no, actually very important, not blah blah blah. They told us that it passes through this point and this point, so they already gave us the points. We don't need to look and like waste our time and use all our brain cells to try and find a point that they didn't even represent it clearly. No, they actually gave us the points. That's very that's very thoughtful of them. Now, the particle is instantaneously at rest. When we're dealing with a velocity time graph, we said when we say at rest, that means velocity initial is what? It is 0. So you'll go to the graph, you'll see, okay, at which time is my velocity initial 0? It's at this time and this time. What's this time? Here they did not help us. We need to find out the value of the time. This is 5, 6, 7, and 8. Then this is 8, 9, 10, 11, 12, and 13. So the 2 times at which it's at rest are... Oh no, it froze. Oh my goodness. No. Okay, there we go. No, it still froze. No, wait, I'm gonna pause a sec. Okay, I got it back to functioning. Okay, so the particle is instantaneously at rest at time 8 seconds and time 13 seconds. Now, the instantaneous acceleration of the particle at time 5 seconds. So they told us at time 5 seconds, they want to find the instantaneous acceleration, and thank God and thank them that they gave us the points of the tangent, right? So they drew the tangent for us, and they gave us 2 points on the tangent. And using these 2 points, we'll be able to find the instantaneous acceleration, which is the slope. So 1 minus y over x minus x, 0 minus 7 over 12 minus 1. That is gonna be minus 0.6 meters, almost approximately, of course, meters per second squared. So minus 0.6 meters per second squared. Question number 15. Ooh, I like this question as well. It's very easy. And you're gonna see as well, it's very easy. Let me just zoom out. A skateboarder is moving along a horizontal path with the velocity of this. That means this is what V initial. The skateboarder pushes off with their foot and 5 seconds the time. Later, the skateboarder velocity became what? It became 12 meters per second. V fine. Perfect. So, the average acceleration of the skateboard. They want the average acceleration of the skateboard. What's the value of average acceleration? It's delta V over delta T. So the change in velocity over the interval of the time. So what's the change of velocity? It's V final, which is 12, minus V initial, which is what? Which is 2 over the time interval, which is 5 seconds. So that's going to be 2.0 meters per second squared. Very simple, very easy, very nice. Perfect. Question number 16. It's going to take another 15 years to load. Okay, I'm just going to pause the video a bit. Okay, question number 16. The velocity time graph of a moving particle is shown below. The dashed line is the tangent to the curve at 1.5. Yeah. I remember here, they were not as nice in this question. They did not give us the points. So I got an approximate value, not the exact answer, and then I just took like the nearest possible value. So the velocity time graph of a moving particle, blah, blah, blah. So they want the acceleration of the particle at time t, meaning they want the instantaneous acceleration. So at time t, which is 1.45, and almost here, they drew the tangent for us. Let's zoom into the tangent. That's like the answers are not exact. And let's choose 2 possible points on the tangent. For example, 1 point is here and 1 point is here. This point is not exact. So this point over here, I chose it. It is what? It is 1.2. Even my tablet's glitching. Hello, that's nice. 1.2. And then this point over here, it's approximately what? Actually, let me just erase this to see. It's approximately 1.2 and 1.01, if I'm not mistaken. Because it's not on 1, it's 1.01. Now, actually, let me check really quickly. Yeah, I got an approximate value. So I'm gonna do what? I'm gonna do y minus y over x minus x. Amazing, my tablet's glitching as well. That's why it's a bit slow, I think, in the video. I'm not sure. by y minus y over x minus x. So that's going to be what? That's going to be 1.01 minus 1.2 over 1.2 minus 1. And that's going to give us an answer of what? Of minus 0.95. So take the closest possible answer, which in my opinion is minus 0.9. So we have to take the closest possible answer, which is minus 0.9 meters per second. Question number 17, very nice question. They want the displacement of the object, knowing that it's a velocity time graph. So we need to find what? We need to find, actually a very important question. We need to find area 1, and we have also to find area 2. And using these two, we need to do what? We need to add their areas. So area 1, it's a triangle, it's gonna be base, which is 4, times height, which is 6 over 2, plus area 2, which is a trapezoid. It's gonna be what? It's gonna be from 8 till 10, that's 2, plus from 4 till 12, that's what? That is 8, if I'm not mistaken, times what? Times the height. What is the height in the scenario? The height in the scenario is minus 6 divided by 2. So you just need to put this on your calculator, and once you put it on the calculator, you'll get your final answer to be minus 18 meters. Very slow, amazing, I love that. Question number 18. Let's move on now to question number 18. A block initially moving at 20 meters per second. So what is this? This is V initial. Is decelerating. Important, very, very important. It's gonna be minus acceleration. At a constant rate of what? At a constant rate of 4 meters per second. So this is our acceleration. Remember, it's decelerating, so it should be minus acceleration. So it should be what? It should be minus 4 meters per second squared. Now, what is the displacement? Displacement is delta x of the block over a course of what? Over a course of 6 seconds. So what do we have? In our given, we have velocity initial, we have the acceleration, and we have the time, and we need to find delta x. So what equation, okay, from either URM or UARM will help us find this? First of all, you remove URM because we have an acceleration. That means velocity is not constant. So we move on to UARM. Which equation of UARM will help us find delta x? If we have velocity, acceleration, and time, very simply, the equation is delta x is equal to 1 over 2 at squared plus v initial t. So let's substitute 1 over 2 times minus 4 times 6 squared plus v initial was how much? 20 times 6. Now it's on your calculator. You need to put it on the calculator and you need to solve, and you are supposed to get an answer of 48 meters. We move on to question number 19. Hopefully this one will not take too long to load as well. I feel like it's either my recording that glitches or the Wi-Fi that glitches, especially now because of what's happening in the Red Sea, and like the cables are cut off and whatever. Okay, question number 19. A car initially moving at what? Initially moving at 30 meters per second. Very important. This is what? This is V initial. Decelerates to 5 meters per second. So this is what? This is V final in 3.8 seconds. They want the acceleration of the car. First of all, they told us decelerates. That means, of course, acceleration needs to be negative. Second of all, we can find it by doing what? By doing V final minus V initial over time. Right? So that's going to be 5 minus 30 over 3.8. Put it on the calculator. Of course, the zero does not want to be continued. And you will get an approximate answer of 6.6 meters per second squared, right? So it is what? It is minus 6.6, my bad. Minus 6.6 meters per second squared. All right. I apologize for the really slow drawing. I think my tablet's glitching. Now, question number 20. Yalla, faster. We have only 5 questions left. I want to post it. I'm going to pause the video for a bit until it loads. Okay, question number 20. The magnitude, very important, magnitude. What does it mean? Absolute value of whatever answer we get, okay? Of the car's acceleration at time 1 second. So at time 1 second, we need to find the magnitude of the car's acceleration. So what do we need to find? We need to find the value of the slope, right? So just choose any 2 points. For example, 0, 3, and this point here, which is 1, 1. And then you're going to do what? And then you're going to do 1 minus 3 over 1 minus 0, so that's going to be minus 2 meters per second squared. But, however, they want the magnitude, so you put it in absolute value, so it's going to be 2 meters per second squared. 2 meters per second squared. Let's go on to 21. What do they want? They want the total displacement of the cyclist. So, how do we find the total displacement again? It's the area of our graph. So, it's a right triangle, like it's a triangle. We're just going to do what we're going to do, base times height. So, the base in this scenario is 80 times the height, which is 6 divided by 2. What is 80 times 6 divided by 2? That's going to be 240. Question number 22. Last 3 more questions. Oh my goodness, it's taking like centuries to load. Don't worry, guys. We're the only thing we have to defeat right now is my slow internet. It's so close. I think it's so close. Do you see it, guys? It's really, really close over here. It's almost gonna make it, but no, it's not gonna make it. It decided to be very lazy today. Okay, perfect. Question number 22. A runner passes the start line at a speed of 1 meter per second, so this is v initial, and accelerates at a rate of this, so this is acceleration. For how many seconds? For 10 seconds. They need the displacement, meaning delta x, for the runner during these 10 seconds. So again, what's the equation for the displacement if we have velocity, initial, acceleration, and time? It's delta x is equal to 1 over 2 at squared plus v initial t. So delta x, we need to find it, is 1 over 2 times 0.5 times 10 squared plus v initial, which is 1 times 10. You just put it all on your calculator and you will get the answer to be what? To be 35 meters. Now we move on to question number 23. The diagram below shows the variation of a car's velocity with time at this point. Okay, at time 1. They want what? They want the instantaneous acceleration of the car at time 10 seconds. So instantaneous acceleration, they gave us the tangent. You just need to find what? You need to find the slope of the tangent. Choose any 2 points, for example 40, 15, and this point here 10, 5, and then do y minus y over x minus x, 15 minus 5 over 40 minus 10. That's gonna be 1 over 3, which is 0.33 meters per second squared. Question number 24. Yalla, faster. I don't think it's gonna go faster. I think it's gonna take its time. Wait. By the way, my video is only like 45 minutes in real time because I'm gonna speed it up. It's only like 45 minutes in real time, so it's like 15 minutes wasted just waiting for the thing to load. Imagine. Okay, perfect. Question number 24. It's a very, very, very important question. They told us that based on the student's data, what's the value of free fall acceleration? Knowing that the y-axis is given to us in meters, meaning that this is delta x, okay? And they gave us the time squared, meaning the time squared, right? And they told us, if you read, of course, and I didn't read because I read it before, but you guys are supposed to read in the exam as well. From rest, what does this mean? This means v initial is equal to 0. That means it starts where it starts from the origin. So what can we say from this? We can say that we have delta x over here. We have time squared over here, and they want us to find the free fall acceleration, meaning A. What equation can we use that has delta x, time, acceleration, and v initial? Even though if v initial is 0. We have v initial equals 0. Time squared, let's just choose any delta and any time. For example, 0.2, and this point over here is 0.9. 0.9. So the time squared is 0.2, and delta x is how much? Is 0.9. And they want us to find acceleration. Very simply, delta x is equal to 1 over 2 at squared plus v initial t. V initial is 0, so anything times 0 is 0. Remove it. So now this is our equation. Delta x, which we said is 0.9, is equal to 1 over 2 times acceleration times what? Time squared. Time squared we said is 0.2. So acceleration over 2 is equal to 4.5. That means acceleration is what? Is 9 meters per second squared. Perfect. That's it. Now, nashkur Allah, the last question. Question number 25. And I think I'm going to write the equations. If 25 loads, I think it's like probably the easiest question. Just need to wait for it to load. I think I've been waiting for like a minute now. See, it's so close. It's still moving though. It's so close. Come on, can do it. You know, every time what I'm having to do, because it keeps on getting stuck here, I keep on having to click on this one, and I keep on having to log in, and then I keep on having to like open the quiz again. Wait, hold on. I did it again, guys, but I still managed to get what? I still managed to get the question. Which of the following is the gravitational acceleration near the surface of Earth? If they give it to you as 10, you will use it as 10. If they don't give it to you, you use it as 9.81 meter per second squared. This is supposed to be memorized like our names. We should have it memorized. So anyways, in all scenarios we finished. Let's submit, and hopefully there are no mistakes, and I'm just gonna write the questions. Sorry, the equations. Perfect. So now let me zoom in here. Perfect. Let me write the equations. For now, we only have two equations, or like two sets of equations to focus on. UARM, which is only one equation, which is x final is equal to x initial plus velocity initial. No, actually there's no velocity initial, plus velocity times time. This is a new UARM. Now, UARM, we have 1, 2, 3, 4 main equations that we need to know, which is velocity final is equal to velocity initial plus acceleration times time. This is if we don't have displacement, so no delta x. Then, if we have delta x is 1 over 2 acceleration times squared plus v initial time. This is if we don't have velocity final. Then another equation is delta x is equal to v final plus v initial over 2 times the time. This is if we don't have any acceleration. And then last but not least, v final squared minus v initial squared is equal to 2 acceleration times delta x. This is if we don't have any time. Also for the projectile motion for the free fall, if we are throwing it upwards, that means our velocity initial is positive. Our acceleration will be minus g. However, if we're throwing it downwards, means that our velocity initial is negative. That means our acceleration is going to be positive g. These are supposed to be memorized like your name by heart, and you're supposed to like recite them blindly. Thank you guys for watching. I hope you enjoyed, and have a wonderful